Sometimes we can use logarithmic differentiation to help simplify differentiation that involves the product of some functions together. So here we have f of x is equal to x squared e to the negative x. So f of x is x squared e to the negative x times 3x plus 5. So if we want to take this derivative, this is obviously a number of product rules here. However, we can use logarithmic differentiation to actually simplify this a little bit. So I'm just going to take the logarithm of both sides. Ln f is equal to ln of x squared e to the negative x times 3x plus 5 cubed. And we can use our rules of logarithms, namely the fact that inside the logarithm there are these three functions multiplied together. So we can use the rules of logarithms to break this up into three different logarithms. Ln of x squared plus ln of e to the negative x plus ln of 3x plus 5 cubed. We can further use our rules of logarithms to bring this exponent down. This becomes 2 ln x. E to the negative x inside of ln is just negative x because of the rules of logarithms. And here, this 3 can come down front and become 3 ln 3x plus 5. So now that we have ln of f simplified in this way, we can take the derivative of both sides. So the derivative with respect to x of ln f is equal to the derivative with respect to x of 2 ln x minus x plus 3 ln 3x plus 5. And now, using our usual rules of differentiation, we have three separate terms here, so we can do the derivative of each term separately. So this becomes 2 over x, because the derivative of ln x is 1 over x. The derivative with respect to x of negative x is just negative 1. And then the derivative of this function here will require the chain rule, so it'll be 3. The derivative of ln 3x plus 5 with respect to x is 1 over 3x plus 5, because that's the derivative of ln, times the derivative of what was inside the ln, which is 3x plus 5. The derivative of 3x plus 5 is just 3. So that's the chain rule there, which then simplifies our function to 2x minus 1 plus 9 over 3x plus 5. So that's the derivative of the right-hand side. The derivative of the left-hand side, we have the derivative of ln f with respect to x, so we're going to need the chain rule here. So we'll take the derivative of ln f with respect to f, which is just 1 over f. And then we'll take the derivative of f with respect to x, which is df by dx. So that's another chain rule there. Of course, at the end of the day, the question wants df by dx, so what we'll have to do here is we'll have to essentially isolate for df by dx. So what we do now is we multiply both sides by the function f. So we have df by dx, which is what the question is after, is equal to our function f times what we had on the right-hand side after doing all our derivatives, 3x plus 5. And of course, we know what f is all the way back up at the top of the function. It says that f is x squared e to the negative x, 3x plus 5 cubed. So wherever we see an f, we can instead put in an x squared e to the negative x, 3x plus 5 cubed times this thing that we had in brackets. So 2 over x minus 1 plus 9 over 3x plus 5. And that's the final answer.